Hey everybody, today we're talking about measures of variation. We've done measures of center and measures of shape. This is variation. What variation means is how far spread out all of our data is. How much does our data vary from point to point? We have a couple different measures that we use. The first thing we need to discuss are quartiles. Quartiles have that root just like quarters. They divide our data into 4 equal parts. Now what that means is not 4 equal lengths apart, but 4 equal parts. So in between every set of quartiles, there's an equal number of data values. That's what we mean by equal. The first quartile is the median of the lower or the first half of our data, which we'll talk about how we find in a second. The third quartile is the median of the upper or the second half of our data. So we have our minimum, we have our first quartile, we have our median, we have our third quartile, and then we have our maximum. The range is one of the most important measures of variation that we'll use, and it tells us how much does all of our data differ. It's the difference between the greatest value, which we call the maximum, and the least value, which we call the minimum. Difference means subtraction, so we can also always take the maximum minus the minimum to find our range. Sometimes we call this top minus bottom too. The interquartile range, so we're taking the same idea of the range, but we're saying it's the range in between interquartiles. So the range is the difference between the third and the first quartile. If we call first quartile 1, Q1, quartile 3, Q3, we can say that the interquartile range, or the IQR, is Q3 minus Q1. Range told us how far spread apart all of our data is. The interquartile range says how far apart is that middle half of our data. From the middle of the first half to the middle of the second half, how big is that range? Let's talk about how we find these. The next slide, sets of notes should all go in that right empty boxes on your note sheets. Okay, steps for finding quartiles. In summary, you're going to find the median 3 times. We first need to put our numbers in order from least to greatest. That's the most important rule, the cardinal rule for finding our median. Then we can go ahead and find the median. So of the numbers listed there, they already found the median for you on the page. We are thinking, okay, we can take 1 away from each side. Eventually we end with 2 numbers in the middle. 2 numbers in the middle, we know that we can take the mean of those 2 numbers, 28 plus 30 divided by 2, to get the actual median, which is 29. Now, in order to find the first quartile, we need to take the median of the lower half of our data. What the median does is it's the middle point, so it divides our data into 2 equal parts. So if my median's right here at 29, half of my data is on this side, half of my data is on this side. Now I see that I have my lower half and my upper half. I can now find the median of the lower half of the data. One thing that's important to note is that since there were 2 numbers in the middle, we could include both 28 and 30 within their respective halves. So let's find the median of the lower half of the data. We're at 22. That is our first quartile. Quartile 1 is 22. Let's find the median of the upper half, or the right side of the data. Again, we include 30. We find our middle balance point. We have 32. Q3 in this case then is 32. Just for practice sake, let's go ahead and find the range and the IQR. Let's first find the range. The range we always know is the biggest value minus the smallest value. What's great about putting your numbers in order is now you can see 37 minus 18. We can quick and easily see what our biggest and our smallest values are. 37 minus 18 gives us 19. Now let's find the interquartile range, or the IQR. We know that the IQR is how spread apart are my 2 quartiles, which means Q3 minus Q1. If Q3 is 32 and Q1 is 22, I get a grand total of 10 for my interquartile range. We'll talk about how we interpret these 2, but just always remember, range are a measure of how spread out, or for how much variability is in my data. Let's try an example together. Example 1 lists the speeds of 12 sports cars. They ask you to find and interpret the interquartile range. We're just going to find it today, and next video will be about interpretation. This one's a little different than before since they give us it in a dot plot. Let's take our dot plot and transfer it to a list of numbers. If I have one dot above 220, I know that there's one value that's at 220. I have two dots above 230, so I know I have two values of 230. What's also great about going through with a dot plot is that we can automatically make sure our numbers are in order since they're already in order on the number line. Two values at 240, one at 245, three at 250, 250, two at 260, and one at 270. You all should make sure you can try to write this in a fully straight line. I just ran out of space here. It makes it a lot easier to see the middle point. So step 1 was to get them in order. Check, we did that. Step 2 is to find the median. So this is why writing them in a straight line is a little bit easier to see. 4, 4, 5, 5. Now I'm left with two numbers in the middle, 245 and 250. In order to find the median, or my middle value, I need to take 245, add 250, and divide by 2 in order to find that exact middle value. We are able to see then that the exact middle value is 247.5, or 247.50. Now, what that means for our data is that our middle is right here. It's in between these 2 points. Again, this is why it's way easier to do if it's all in a straight line. Now I need to find the median of my lower half of my data and my upper half of my data. The median of my lower half of my data is the Q1. And again, I have two numbers left in the middle. When I have two numbers left in the middle, I have to find that middle number by taking the mean of those two. If I add those two together and divide by 2, I would see that the middle number, or Q1, is 235. Q3, on the other hand, is the mean of the upper half of the data. So median, of the upper half of the data. So let's find the median there. Two numbers in the middle again. The number that's directly in between 250 and 260 is 255. In order to find our IQR then, we need to take what is the third quartile minus the first quartile. So in this case, what is 255 minus 235? 255 minus 235 is 20. My IQR is 20. Since these are all speeds, I know that my IQR is 20 miles per hour. Next video, we'll talk about how we interpret this. Try the on your own section and bring it back to completed for tomorrow.